Today I would like to talk about parallelization of operators. And this is a case in streams where you may want to have an operation optimized across multiple streams so that you can get more performance out of your entire application. Oftentimes in streams you have one operator that you're working on that can actually be a bottleneck to the process. So you want to be able to create multiple instances of it so you can actually flow data through faster. But there's a few considerations around this that I want to talk about. Stream computing in general, streams are stateless. That is, they don't really know what came before them or what else exists in the data or even in the rest of the application. However, there are a few cases whereby you can include stateful operations to improve your application. It may be a requirement. For example, you have the ability to look at tuple history. That is, what was the previous tuple or a few tuples back to look at. Now, in general, you wouldn't want to look at the entire set of data. That would be more of a database kind of operation than a streams operation. But if you want to know how trending is going and things like that, you can look at previous tuples in order to determine that. Another use of state operations is within Windows. That is, we talked in a previous video about using windowing operations where you're looking at data, maybe 100 tuples or maybe tuples over a period of time, and then you look at the next window and the next window. Within each of those windows, you can look at aggregate values and values within that window also, and that's another way to do state. Another alternative for managing stateful operations is through custom operators. Obviously, if you're writing your own operators in Java or primitive C++ and stuff like that, you can control state however you want, but be careful about performance implications. Now, doing state management can impact the output of your application in some interesting ways. And one example I want to show with that is the join operator. And in general, a join operator says if I have data coming in, it's like A, B, and C on two separate streams, and I want to join them together. The output in this one join operator would be A, B, and C. That is, all of these would match. A would match A, B would match B, and C would match C. Therefore, you get a join going out. And this is very similar to a database join, obviously, also. But what if I'm spreading my data across multiple operators, and I have data coming into all of them? So if I have a join 1 operator here, a join 2 operator here, and a join 3 operator here, and this one, for example, gets data coming into it that says A is coming in on one and B is coming in on another. This one, B is coming in on one and B is coming in on the other, and we'll say this one is getting A and C. Well, only one of these operators is actually going to pass data through it where it match, which is this one here where you're going to get a B. This one here, because they don't match, they aren't going to have values flowing out of them. This may or may not be a problem for your application, but it's certainly something to take into account. One of the ways that we can actually fix this problem so that they can all find matches is prior to bringing the data in, we actually partition the data. And that says, hey, all of the A tuples are going to come in up here, all of the B tuples are going to come in here, and all the C tuples are going to come in here. And there's an operator for doing this. A couple different mechanisms like windowing, partitions, and things like that in order to get them to flow in this direction. But in this case, you'd get an A value out here, B would match B, and C would match C, so you get a C value out here. This is what we call joining data in stream. But remember, it isn't data at rest. This isn't data in database tables. This is data flowing through, 5, 10 million rows per second kind of stuff, where it actually is joining this in real time. So you want to be very cognizant of your performance implications of doing this so you don't slow that data down. Now, the other interesting thing that we can do to improve the performance and to parallelize our operations is there's two strategies here. One is called pipelining, and pipelining is also very similar to any sort of framework or flow-based architecture in the database world, where I break things down into discrete operations. I can say, here comes a tuple coming in, say it's an A, B, and a C, and I have a couple different operations, operation 1, operation 2, and operation 3. And all the tuples come through all of these. And I can, if my application supports this, I can then replicate this across multiple hosts So the same type of operations can run across all of them. Now, this may or may not work for you because you may not have the processing horsepower to reassemble this out at the end. Deduplication, there's all kinds of implications of it. But again, these are all just design patterns that you can take advantage of within Streams. Also within Streams, though, there's something called parallel pipelining. And what you do there is you actually, your incoming values here, you actually split them out, and you have operator, this will be operator, we'll call this 2A, 1A, 2A, and 3A here, and I flow data through them this way, and then I reassemble it out here. This parallel pipelining basically allows me to take advantage of parallelization, that is things running on separate hosts, but I can co-locate all of these similar pipelines on a single host so that all of the tuples coming in are going to flow to one of these hosts. And an advantage here is that these hosts can actually run at different velocities. So if your data is coming in from a lot of different sources at different velocities, doing a parallel pipeline approach allows you to take advantage of putting those different speed of delivery on different hosts, and again, getting the same results out the other end. So these are just a couple interesting design patterns around Streams, and we'll be talking more about some other ones in the future. If you want more information, contact me at fblau@brightlightconsulting.com. Thank you.